All right, so we're looking at Unit 5, Part B, number 1, A through D, and focus. And, it's listening to me. Okay, so graph of G is given. We know f of 0 is -1, f prime is this. It's 5. So part A says find the x-coordinate of each critical point of f. Classify each critical point. Okay, so let's find the critical points and then classify them. So critical points where the first derivative is 0 or undefined. So this is my derivative. I'm going to set that equal to 0. You can set each of those equal to 0. So e to the x equals 0, x squared minus 5/4 equals 0. Well, e to the x, if you remember, it looks like this. So it will never be 0 because there's a horizontal asymptote at 0, y equals 0. So that has no solution. So set that equal to 0, x squared equals 5/4. So x equals plus or minus the square root of 5/4. Those are my two critical points. Okay, so we want to know if they're mins or maxes. So we have to find the second derivative. So f double prime of x equals x squared minus 5/4 times the derivative of e to the x, which is e to the x, plus e to the x times the derivative there, which is 2x. There's my second derivative. Using the second derivative test, I can go f double prime of the square root of 5/4, and that gives you square root of 5/4 squared, which is helpful. Plus e to the square root of 5/4 times 2 square root of 5/4. All right, so square root of 5/4 squared is 5/4 minus 5/4 is 0. So this whole thing ends up being 0. Plus e to some number, positive, times some positive number is whatever that is. So we get positive. So if my second derivative is positive at square root of 5/4, that means it's concave up. Therefore, it is a minimum. So at square root of 5/4, minimum. All right. So f double prime of the negative square root of 5/4. Second derivative test there. Plug it in. Well, if you're going to plug negative square root of 5/4 quantity squared, that's going to give you 5/4. So this whole thing is going to be 0 again. Plus e to the negative square root of 5/4 times 2 times the square root of 5/4 negative. All right, so e to the negative is still a positive number. E is always going to be a positive number. So that's a positive times a negative. So we're going to get a negative result. So if it's negative, that means it's concave down. Therefore, it is a max, maximus, or maximum. All right, so there's a max. Okay, so that was part A. Part B, find all the values of x in which the graph of f has an inflection point. Okay, so an inflection point, there's got to be a change in concavity. In order for a change in concavity to appear, the second derivative has to be either undefined or 0. So we have to find the second derivative, f double prime of x. Oh, we already did that. That'd be right here. So set that equal to 0. This is part B. So 0 equals, I'm going to factor out an e to the x right here. So 0 equals e to the x factored out. I have x squared minus 5/4 plus a 2x. So clean it up just a bit. X squared plus 2x minus 5/4 equals 0. Well, we know e to the x equals 0 is no solution. So this one you could quad it or you could factor it. It's probably easier to quad it. A is 1, B is 2, C is negative 5/4. And according to my calculator, that was fun. And I get 1/2 and negative 5/2, or 0.5 and negative 2.5. Okay, so 0.5 and negative 2.5. So those are points of inflection. You can say then at those points there's a change in concavity, or the second derivative changes sign at those points. So you know there's an inflection point. The answer guide did not say that, it didn't show that it happened, but you should state that it happens, because just having a second derivative equal to 0 is not sufficient for there to be an inflection point. Likewise, if the second derivative is undefined, it does not necessarily mean there's an inflection point. There has to be a change in concavity. So state that in your answer. Change in concavity occurs at those 2 points. All right, part C. So we're now looking at G. We're done with F stuff for now. So looking at G, we've got a table. Here's our table given to us. And at x equals negative 3, G is 0, G prime is 0, and G double prime is 0 at negative 3. So at negative 3, G of 0, well, yeah, that's the y value. So G of negative 3 is 0. I think I might have said G of 0. So G of negative 3 is 0. G prime of negative 3 means what's the slope at that point? That's 0. And the second derivative at negative 3, they're saying is 0 also. So there is no concavity. It's not concave up or down at negative 3. Okay, those are just given to us. Now, between negative 3 and 0, what do we know about G? It's positive. Yeah, between negative 3 and 0, my y value is positive. It's above the x-axis, so G is positive from negative 3 to 0. Then they want to know what G prime is. So G prime represents the slope. The first derivative is the slope. Well, the slope, it is increasing that entire time. G is increasing, so G prime must be positive in that interval. And G double prime has to do with concavity, the concavity of G. So this is holding water, so it's concave up, so the second derivative would be positive also. All right, so let's see if we can jump all the way here. So between 0 and 3, G is positive. Yeah, between 0 and 3, G is above the x-axis, so it has a positive y value. G is positive. G prime between 0 and 3. Well, that means is G increasing? Yes, it increases the whole time, or the slope is always positive. So G prime must be positive between 0 and 3. G double prime has to do with concavity between 0 and 3. Between 0 and 3, it is shedding water. There's an inflection point at 0, so it is now concave down. So the second derivative would be negative between 0 and 3. All right. Lastly, part D. What do we got? I'll go black right here. Let's see, part D. All right, H is equal to f of x times g of x. Is H increasing or decreasing at 0? Give a reason. Okay, so let's find out. Increasing or decreasing has to do with the derivative. So we're going to find H prime of x equals f of x times g prime of x plus g of x times f prime of x using the product rule. We're looking at 0. So now let's see what we have at 0 and determine whether H is increasing or decreasing. All right, so f of 0, well, that is given to us. Way back here, f of 0 is negative 1. That's very helpful. G prime of 0, the derivative at 0. Well, if you look at the table, G prime, if you look at the table, G prime of 0 is 2. Or from inspection, you can look that the derivative or the slope at 0 is positive. So I'll say 2, even though for sure we know based on the graph it's positive, but it's actually given to us to be 2. G of 0 is 2. That is the y value at 0, that is 2. And f prime of 0. So f prime of 0. So if we look back at f prime, if I plug in 0, I get 0 squared. I'll do it down here. F prime of 0 equals 0 squared minus 5/4 times e to the 0. E to the 0 is 1, negative 5. Okay, so we get negative 5/4. So what do we know about h prime of 0? We get negative 2 minus 10/4, 5. We get, well, I don't know, what is that? Negative 9/2.
I did it too.
Negative 9/2, maybe? Okay, you don't even have to know that. You just need to know that it is negative. And if it is negative, h is decreasing since the slope is negative. And there you go. 11 minutes.